Hello to all of you, this is Dr. Dhaval Maheta, and today we are going to talk about regression analysis in R. Basically, regression analysis is carried out when level of measurement of dependent and independent variable both are incontinuous. The examples of this are blood pressure, age, weight, height. So let us see how we can carry out the regression analysis in R. Let's go directly into the script file. There is one data set which is empty cars. In this, the variables are miles per gallon, number of cylinders, displacement, horsepower, D-rate, the weight of the vehicle, Q-set, vertical and straight engine, automatic and manual. V and S means 0 for vertical, S for 1 is for straight, automatic A is coded as 0 and manual is coded as 1, number of gears and number of carburetors. Now I want to see that what are the factors which are influencing the mileage of the vehicle, and therefore I'll run the model 1 LM. LM is linear model. I'll make MPG as a dependent variable. I'll use tilde, displacement plus cylinder plus horsepower plus D-rate plus weight plus Q-set plus carburetors. So when I run it, I'll get some result, model 1. But to get the proper result, I'll go in summary model 1. Now there are three things which we will always see in regression analysis. The first thing is that is the model significant or not. The model significant means that I will carry out the ANOVA test, which is given in default in regression analysis, and the null hypothesis of this is model does not exist. This same thing can also be written as all the independent variables are not jointly influencing the dependent variable. It can be written in this way also. And the test which is there for this hypothesis is ANOVA. And here is the p-value for that test. So what is a thumb rule? The thumb rule is if the p-value is less than 0.05, we reject null hypothesis, means we will be rejecting this thing. The desirable is that we reject the null hypothesis, and you can see here the value is 1.284 e raised to minus 8. It means that it is quite significant. So this is related to ANOVA. The second thing which we have to check in regression is the t-test. The t-test is done for individual variables. See, this is a t-test which is run for individual variables, and the null is coefficients are not significant. Coefficients of variables are not significant. The alternative is coefficients are significant. Again, the desirable thing here is we should reject null hypothesis, right? In some books it is also written as null is equal to, they write it as b1 is equal to b2 is equal to dash 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 equal to 0. It means that any of the independent variable is not affecting the dependent variable. So the desirable is that we should reject null of both t-test and ANOVA. It means that we should be having a p-value here which should be less than 0.05, and then only we can say that this variable is significantly contributing towards the dependent variable. So this is the second thing which we should see. Then we should talk about R-square, this one. The desirable range of R-square is between 0.6 to 1. It means that the explanatory power of the model, the R-square means it's an explanatory power of model, also known as coefficient of determination. So if I talk in terms of percentage, this is 85%. Now, what does this mean? It means that all these variables which have been included here, they are able to explain 85% variance in the dependent variable, which is mileage, MPG, right? More coefficient of determination, better is the model. But there is something which we will have to understand, that there should not be a significant difference between multiple R square and adjusted R square. Adjusted R square means gives me the corrected figure, that all those variables which are insignificant, still they are in the model, and after removing them, what I am getting the R square. So there should not be a significant difference in R square and adjusted R square. More or less they should be nearer to each other. So in any regression model, we will be evaluating the p-value of the ANOVA, which is this hypothesis, then the p-value of the individual variable, which is t-test, and the R square. After the model is constructed, we carry out the analysis, which is residual. I am splitting my window into 2 by 2. I'll run it. And on right hand side, you can see some graphs which have been generated. Now these graphs are residual versus fitted, normal QQ plot, scale to the location, residual versus leverage. Okay. Now let us see the interpretation of first graph, residual versus fitted. Basically, this indicates that the model fits well or not. It also tests the assumption of linearity, which states that the dependent variable and the independent variable should be linearly related with each other. The red line which you can see here, no, it should be straight and it should be very close to the dashed line. If it is so, then we can say that the linearity assumption has been met. In this case, the red line is not straight, which means that there may exist a polynomial relationship between dependent and independent variable. Moreover, you can also see some observations like 17, 18 and 20. They are outliers, which may badly affect the result of the regression. If a line is having a same pattern like parabola, it means that the model does not meet the linearity assumption. So the healthy residual plot of the scatter diagram is, it should look like a scattered stars in the night sky. So we can see the assumption has not been met, right? So how do we interpret about normal QQ plot? So if errors are precisely normally distributed, then all points would lie on the straight line, normal QQ plot. The assumption of least square regression is that the errors are the points which lie pretty close to the dashed straight line. The residuals are always present in the model and their deviations are expected from the straight line, but the deviation should be very small. See the deviation, this deviation should be very small. Moreover, 17, 18 and 20 are outliers. They are automatically flagged by the software. Next comes is scale location. It's basically another assumption that is related to homoscedastic. So in homoscedastic assumption, the variance in the residuals does not depend on the value of x. The red line here shows the trend. Okay, so it means that this assumption is also violated. Moreover, 17, 18 and 20 are again outliers. Let us talk about residuals versus leverage. So basically it shows a plot of leverage against standard residuals. So there is a measure to evaluate the influence of each data point on regression model, which is known as leverage. So how much each point is influencing, that measure is known as leverage. The influential point, this may or may not be outlier. See, till we have heard in in many lectures or in many books it is written that outliers are bad. But this plot precisely tells us that even though the outliers are there, are they influential or not? Right? Are they influential or not? Okay. Now, as these outliers are influential, their presence or absence in the model can definitely alter the results of the regression model. In this plot, you can see that this horizontal dashed line should be nearer to the red smoothened line, and no points should have a distance which is larger than Cook's distance. Now this dashed line you can see this one, it's a Cook's distance. This point should not be beyond this Cook's distance. Cook's distance is also known as an influential statistics. So you can see the observation number 17, 20 and 31, though they are outlier, they are in the range of Cook's distance and they are not going to influence your regression results. Is it clear? They are not going to influence your regression results and therefore no need to worry. Okay. But to make the model better, let us use some another model in which all those variables which were insignificant, let us remove them. So how we will remove them? The highly insignificant variable or whose p-value is very nearer to 1, we will start removing that variable. So I am making another model, model 2, run, just a minute. I will run this, attach, run, just a minute, let me run this model 2, run. Now let us see the p-value. You can first let us see the p-value of the ANOVA. It's less than 0.05, so we can say all these variables are jointly influencing the dependent variable. Fine. Here you can see the cylinder is affecting, the weight is affecting, but displacement is not affecting, and therefore this can be the variable which we will have to remove in the further models. Let us see R square. The difference between R square and adjusted R square has decreased, and therefore this model is considered to be the better version of the earlier one. Let us see the residual diagnostics again. Run it, and you can see there is some smoothing which has happened. This red line is now near to the dashed line, and more or less there are some corrections in all the 4 graphs which have happened. Good one. Now is there any package which can carve out the good model from the data or not? Definitely we are having one package which is known as mass. Activate the library of the mass. We very well know how to install the packages. You can see in my earlier videos in which I have discussed about activating the packages. Kindly go on to my playlist of R and you will be able to see all the previous videos. Once this is done, I will run the model mask lm. I will insert all the independent variables and then I will pass the command step AIC mask direction both. Direction both means you have to include and exclude the exclude the variable simultaneously. Run and run. Now it will carve out the model on the basis of AIC criteria, that is a Akaike information criteria. It will try to lower it as much as possible. So you can see AIC in the first step is this much, where all the variables were there. Even those variables were also included which were insignificant. Now it started removing the variables and ultimately it reached to the last step in which AIC criterion is 62.6, and it found that there are only 3 variables which are significantly contributing towards the dependent variable, that is mileage. You can also compare the models. For this, you can carry out the ANOVA. So what is a null hypothesis? Null is model 2 is better than model 1, or in other words, simple model is better than the complicated model. H1 is model 1 is better than model 2, or complicated model is better than the simple model. We know model 1 is more complicated than model 2 because it is having more variables. Let us run the analysis. We got the p-value which is more than 0.05, and therefore we fail to reject null hypothesis. This means that model 2 is better than model 1 naturally. Simple model is better than the complicated model. You can see the p-value is more than 0.05, and therefore we fail to reject null hypothesis. Let's proceed further. Sometimes in regression analysis we also consider the interaction effects. So here I am including the interaction effects, that is cylinder multiplied by weight. Okay, directly cylinder multiplied by weight. Actually we should standardize these variables, but for at present, for understanding what is interaction effects, we are directly including cylinder into weight. So I am saying that the cylinder and weight, they are not going to work in isolation. There must be some interaction effects which must be there. Naturally, what the concept is, as number of the cylinders will increase in the vehicle, the weight will increase, and on that, so cylinder and weight both are going simultaneously, and is there the joint effect of this or not? We want to run this. When we'll run, I'll get this. So you can say cylinder into weight has also got the effect. The interaction effect is also there. R square has increased, adjusted R square. There is no significant difference in R square and adjusted R square, which is really good. P-value less than 0.05, which is also good. Now here there are some stars. 3 stars means highly significant, 2 stars means moderately, and 1 star means significant. You should have stars which indicates that this variable is definitely contributing to the variance of the dependent variable. You can also have the polynomial regression, that why we are considering that weight must be affecting linearly only to the mileage. It may be the possibility that the square of the weight may be affecting. And when we want to include such term in our model, what I'll say, mpg tilde cylinder plus weight plus I you have to include into bracket weight raised to 2. Run. You can see that the power of weight is also significantly contributing, right? Now you have to evaluate all these models in terms of residual diagnostics also, and t-test, ANOVA, and t-test, ANOVA, and r-square also, right? Now there is one library which is GBLMA. The library name is GBLMA. The full form of this GVLMA is Global Validation of Linear Assumption. Basically, it will try to test that is the model able to clear all the basic assumption of linear model or not. Let us activate it. I'll run the first model. The command line is gvmodel. Gvmodel is a title, you can give any title, but GVLMA is a command. Insert your first model 1 here and run the summary. It will directly give you the report card. Global statistics assumptions not satisfied. Skewness assumptions acceptable. Kurtosis assumptions acceptable. Link function assumptions not satisfied. Now here link function means that is your model following the linearity or not, or we will have to use another link, means binomial or something like that. We will have to use such type of models or not. So here link function is for that. Heteroscedasticity assumptions acceptable. Let's proceed further. Now there is one package which is Stargazer. Activate the Stargazer. At a time, you can compare two models, model 1 and model 2, and you can report this thing in your paper directly. You can see how it's giving you the output: dependent variable, MPG, displacement, cylinder, HP, D rate, which are the variables which are included. Observations, R square, there is a comparison between two models, adjusted R square, residual, F statistics is there. So it gives the result in much more organized form. Still, there is one more library that is known as JTools. Activate the libraries. Also activate the library Broom, library GStance, library Broom Mixed, and just you have to write down summarize the model 1, and it will give you the output in very much organized format, just like the professional softwares. You can see it is giving me the F statistics. This is ANOVA. The R square is there, adjusted R square is there, P value is there. If you want the variance inflation factor, or rather is there any presence of multicollinearity between the model or not, between the variables or not, so you have to just write down VIFS is equal to true. Run it, and the command line is plot underscore coefficients model 1. On first it will give you the plot on right hand side. Now how to interpret this plot, let us understand. Those variables which are dissected by the zero line, it is just like a Turkish test which we had done in ANOVA. See in my previous videos of ANOVA. The variable whose confidence interval is dissected by the dashed line, these variables are not significant. Okay, these variables are not significant. You can see displacement, cylinder is not significant, HP not significant, D rate not significant. The highly influential variable is weight. QSEP and carb are also dissected by 0. Weight is not dissected by 0 axis line, and therefore weight is highly influential variable in regression. Right? There is one more package which is OLSSR. Run it, and you will have to write down OLS underscore regress MPG displacement horsepower weight, and run it, and you can see it also gives you the output in much organized format, just like the professional softwares. Now after all this thing is done, finally you have to make one model. Say for example, our model is now consisting of these 3 variables. Let me pick up these 3 variables. Just a minute. Now my final model is that the MPG is getting affected by cylinder, weight and horsepower. I'll run the model. Now let us check the ANOVA. Is it significant? Yes, it's significant. Are individual coefficients significant? Weight and horsepower are significant. Cylinder is still not significant, right? R square and multiple R square and adjusted R square are more or less nearer to each other. Let me remove cylinder also now, and let me talk about only weight and HP. I'll run it. Now let me see, is the model significant or not? P value highly significant. See the difference between R square and adjusted R square. It is more or less nearer to each other. Individual variables, are they significant? All are in 3 stars. It means that this model is highly reliable model. Let me have the statistics which is related to residual diagnostics. To the matter of the surprise, now this line has become more, you can see the curve is there, but anyway, 17, 20 and 31, though they are outliers, they are not going to affect our regression model because they are inside the Cook's distance. Cook's distance is the dashed dotted lines. If this variable, if this observations were beyond this, then we would have to worry. Otherwise things are normal, nothing to worry. Now this model has been constructed what we can do with this model. So I'll say my MPG is equal to, just pay attention here, MPG is equal to 37.22. That is a constant which is there in every model, minus 3.87 times of weight, right? We always take the unstandardized coefficient, this one, this into this, minus 0.031 horsepower, right? This is the model which we have constructed. Now what is the meaning of this model? Let's try to understand. With every increase in the weight, 1 unit increase in the weight, the mileage of the vehicle decreases by 3.87 units, right? For every increase in horsepower by 1 unit, the mileage decreases by minus 0.031. This is a very known fact, that as the weight of the vehicle increases, the mileage decreases, and we have proved the same thing with the help of regression analysis. All these codes are available in my book, which is Data Analysis Using R, which is available on amazon.in as well as amazon.com. You can subscribe to my channel. You can follow me on LinkedIn and Twitter. Thank you.